all the way, please?
Okay.
Okay. So today, guys, we're going to work on solving exponential and logarithmic equations. We've done a lot of this. We just need to add another layer of kind of complexity to the equations. If you're given an equation such as 2 to the x equals 6, we know how to solve it. It's in exponential form. We're going to rewrite it in logarithmic form. But what if you're given an equation that says 3 minus 2 to the x equals negative 6? Well, the first thing is going to be to get the exponential term by itself. Our goal is to make these look simple like we did before. So my first step here is to get the exponential term by itself by subtracting 3 from both sides. I'm left with minus 2 to the x equals negative 9. And a lot of times people will be tempted to rewrite it in logarithmic form here, but a rule that we need to talk about is that you can't take the log of a negative. Okay? So my next step actually is going to be to divide by negative 1. What this is going to give me is 2 to the x equals positive 9. This is something we've seen before. It is in exponential term form. We want to rewrite it as in logarithmic form by taking the base of the exponential term and making it the base of the logarithmic form. Then take the answer, put it second, and then take the exponent and put it over there. At this point, we've learned how to do this in that we can't put it in our calculator just like that, but that we can do log of 9 divided by log of 2 equals x. When you put that into your calculator, you get 3.1699 equals x. Now the only new thing we want to introduce here, guys, is that this has a name, this step. What this step going from base 2 of 9, log base 2 of 9, to log 9 over log 2, this is called the using the change of base formula. So even though it's kind of called a formula, you guys already know how to do this. You just take the base of the second, or you take the large number after the log and divide it by the log of the base. Okay? This is not new. This name is something that you'll see. Okay? You will now see change of base formula. It just means to do this. And the only other thing we can say is that we did round here, and so we want an approximate sign. Thank you, Tanner. All right. The next type of equation we want to look at is something that looks like, you will see some that are 3 to the x plus 4 equals 101. At this point, we have, even though there's an x plus 4, it's all in the exponent, so the exponential term is by itself. So we can immediately write it in logarithmic form by putting a log. Base of the exponent becomes the base of the log. So log base 3 of 101 equals the exponent, which is x plus 4. When you have this, we're going to use what we now call the change of base formula to say log of 101 divided by log of 3 equals x plus 4. If you do that on your calculator, log of 101 divided by log of 3, do end up with 4.2008 equals x plus 4. Now we use our basic algebra skills to subtract 4 from both sides, and you get 0.2008 is approximately x. Alright. There will be problems on your homework also that say that just look simply like this, and they say evaluate using change of base. So eval using change of base. All I want you to do on those problems is log of 10 divided by log of 3. Notice no equal sign in my first part, no equal sign in my second part. And you get 2.0959. Now the only other piece we want to look at is how are these going to get a little bit more complex using our properties of logarithms. So what these ones look like are something like log of x minus log of 3 equals 8. When we have an example like this, we notice that we have subtraction here. Well, we can't just rewrite it in exponential form because we have more than one log. Can we simplify these logs to have only one of them? Well, if I have a minus, I take this and I divide by that. So x divided by 3 equals 8. This is the other piece we have not gone over yet. To rewrite this in exponential form, I need a number here. And just like when we had a square root, we don't write what the index is, but there really is an index there. It's a 2 with a square root. Here, when we don't write the base, it really is the number 10. What this is called is the common log. So if you ever have a logarithm without a base, the base is really 10. And that leads us to the base of the log is going to be the base of the exponent. So I get 10 to the 8th equals x over 3. I took the base, made it the base of my exponent, I took the answer and made it my exponent, and I took the number after and made it the answer. At this point, guys, you've got just one step to complete this. We need to get x by itself. If it's x divided by 3, I need to times by 3, and times this side by 3 here. Now, one thing I'll say about this, we can easily write this number out as 10 with 8, or a 1 with 8 zeros, and then multiply it by 3, it would be a 3 with 8 zeros. That's a really big number. When you have large numbers with that, use scientific notation, which just says, we can say 3 times 10 to the 8 equals x. Which is really all this says, just without parentheses and with the actual multiplication sign in there. So, steps to do this: combine to a single log using your properties of logarithms. Then rewrite in exponential form. And last, we want to solve. And those are the 4 types of problems you'll see on your homework tonight. Pretty simple, straightforward, except now we're just combining the properties of logarithms and rewriting in exponential and logarithmic form. That's it.